All right, guys. I wanted to make a quick video on some of the properties of radicals since talking to a few of you, you just kind of seem to be struggling to remember some of these Algebra 1 um, facts or properties here. So first thing we want to talk about is the addition property, or more specifically, the lack thereof. There is no addition property for radicals. Let me show you what I mean by that. So the first thing, I'm going to do this. We're going to look at an example real quick, a really easy example, I hope. So if I've got the square root of 4 plus the square root of 9, the question is, can I add these two together and combine them under one property? So does that equal the two things added combined under one radical? All right, so again, going back to this example, we're going to see if does this equal the square root of 13? Well, we know what the square root of 4 is. The square root of 4 is 2. We know what the square root of 9 is. The square root of 9 is 3. So the question is, we know that 2 plus 3 is 5. Is 5 the same thing as the square root of 13? And I think hopefully all of us can answer no, that is not, that does not work that way. And so what happens is anytime you are adding two radical expressions together, you cannot combine into one. There's nothing we can really do in order to combine these two things. The only time that you can combine is if you have the same expression. So if I have, for instance, the square root of a plus the square root of a, I've got two of the same expression. And so now I can combine these into, I've got one of these and one of these. I now have two square root of a's. That's the only way that we can add radical expressions together. So we have to have the same radicand. It's called a radicand, but uh, we're just going to say we have to have the same thing inside, same expression inside the radical in order to add. Otherwise, don't add them together. All right, next property of radicals that we want to look at is what's called the product property. So if I'm multiplying two radicals together, they have different bases. Notice underneath they have different, not bases, radicands or expressions inside the radical. I can add them to combine into one radical. So again, what we talked about up here, the addition property, we cannot combine those two into one radical, but when they're being multiplied together, we can combine them into one radical. Okay, so an example of where this might be useful, if I've got the square root of 18 and I'm multiplying that by the square root of 2, either one of these can really simplify into a nice whole number, but what we can do is combine those into one radical so that we have 18 times 2. We know what 18 times 2 is. That's the square root of 36. And I know the square root of 36, that's equal to 6. So sometimes this can be useful to give you a nice, simple whole number answer. Other times, maybe not so useful, but this is one of the properties. It's called the product property of radical. Next thing we want to talk about is the quotient property. So in other words, when we have one radical being divided by another, one radical here being divided by another, we can also combine that into one nice big radical, and we can divide the radicand on the top by the radicand on the bottom and put everything under one big radical. We can also go backwards on all of these properties. So I can take one big radical and break it up into two separate radicals and simplify from there. So we'll show a couple quick examples here. If I've got the square root of 8 over the square root of 2, now I can simplify that by breaking the top apart, but I can also just say, well, I know that this is equal to those two underneath the radical, the square root of the fraction 8 divided by 2. And that simplifies really easily for us and is pretty helpful. So we got the square root of 4 because 8 divided by 2 is 4. And I know what the square root of 4 is. It's 2, and I'm done. So we can use this property to kind of combine, take two pieces and combine them into one piece that's really easily simplified. Another example, Let's start and kind of go backwards here. So we want to start with one big radical, or the square root of a fraction. I've got the square root of 25 over 3. So again, I can break that into two parts. The square root of the top, or the numerator, divided by the square root of the denominator. I can simplify the square root of the numerator because I know that's square root of 25 is 5. And my denominator can't simplify any farther, so I end up with that answer. So this leads us to the next, it's not a property, but it's something that we always do when we simplify radicals. So notice this answer right here, we've got a radical in the denominator, and most of the time we want to do what's called rationalizing. We want to rationalize this denominator, and what that means is get rid of the square root or any root in the denominator. All right, so here's just a quick example of how to do that. You see in this example, we've got the square root of b, we've got a square root in the denominator, and we want to make sure that we get rid of that square root in the denominator. So I'm going to rationalize. And the way that I actually get rid of this is kind of interesting. I'm going to multiply by a fraction. And the only way that I can multiply by something, multiply an expression by something without changing it, is to multiply it by 1, by something that is equivalent to 1. And so here what I'm going to do is I'm going to multiply it by the square root of b over the square root of b. And again, the reason I can do this is because anything divided by itself is just equal to 1. So I'm not changing the original expression by doing this. I'm not changing the value of the original expression by doing this, but I am going to change the form, and I'm going to make an equivalent form that is rationalized. All right, so let's go through this process. Anytime I multiply fractions, I multiply across. So when we multiply the denominator, I've got the square root of b times the square root of b. In the numerator, I've got the square root of a times the square root of a, or sorry, the square root of b. And in the denominator, we can simplify this. We can take this one step farther, combine these two, and that's b times b, which I know is b squared. And that gives me a nice expression, the square root of b squared. I can simplify just into a b. Up top, we'll combine these two, and I would get the square root of a times b. So taking it one step farther, we've got the square root of a times b in the numerator, and just a simple b in the denominator, and I now have my expression rationalized. So there is no square root in the denominator. There's only one in the numerator, and we're good to go. We're rationalized. We've got an expression that is simplified. So let's go back up to this example. Here, if you want to pause the video and go through this example, you can, but we ended up with an expression that looks like 5 over root 3. So we want to make sure that we rationalize that, get rid of that square root in the denominator. So the way that we do that, just multiply by whatever's in the denominator and get rid of that square root. So I multiply by the square root of 3, but I can't multiply by that. I got to multiply by 1 so I don't change the overall value. So this expression, something over itself, is always going to be equal to 1. Go through and multiply. Multiply our denominators. Square root of 3 times the square root of 3 is the square root of 3 squared. And then in the numerator, I get 5 times root 3, and I can't do anything to simplify this. One more step, 5 root 3 in the numerator, can't do anything to simplify. In the denominator, I know that the square root of 3 squared is just 3, and there's my simplified expression that is rationalized.